Welcome to Season 2 of RS&H's podcast called AEC Perspectives. We're excited to bring you more episodes that highlight and showcase important topics, thought leaders, and ideas around architecture, engineering, and consulting. For our first episode in Season 2, I am excited to be joined by RS&H's National Bridge Practice Leader, Matt Chynoweth. Matt is a National Bridge Group leader at RS&H, and he came to RS&H after 20 years of working as the Chief Bridge Engineer for the Michigan Department of Transportation. While there, he earned ASBI's Leadership Award in 2020 for his career contributions to the industry. Matt has also received the AASHTO Sweet 16 Research Award for his work in CFRP pre-stressing, post-tensioning of concrete bridge elements, and he served on the executive committee for the AASHTO Committee on Bridges and Structures. Matt holds a Bachelor's of Science in Civil Engineering from the Michigan State University and a Master of Science in Structural Engineering from Wayne State University. Matt also teaches graduate engineering courses as an adjunct professor for the University of Michigan, Ann Arbor, and Lawrence Technological University. Matt is a runner and is passionate about the future of our industry and participates on many different committees focused on bridges and structures. Matt, welcome to this episode, starting off our Season 2 of AEC Perspectives.
Thanks, Brian. Thanks for having me.
It's so good to see you and be with you, and I appreciate you joining me. We're going to jump right into our questions. I want, if I could, to ask you to share some details about a particularly challenging or memorable bridge project you've worked on. And I'm sure there are a number of them. So pick one or two and let's talk about that.
Sure. So I've worked on many bridge projects, from just being starting at the design stage, being a project manager, working through design, working through construction, all sorts of bridges here in Michigan. The most memorable one, and the one that, it's near and dear to my heart in terms of its complexity and then the success we had, was about 10 years ago. We had to replace all the bearings, very large bearings, on a large post-tension concrete segmental bridge in mid-Michigan, I-75 over the Saginaw River. And this was a bridge that, when it was built in the early to mid-'80s, it was fraught with issues. It was one of the first precast post-tension segmental bridges in the U.S., definitely a first for Michigan. There were a lot of issues with its initial construction, and therefore there was a lot of issues with public trust in this bridge during its years of operation. And very long spans. It's twin bridges, 8,100 feet, with a main river span length of 395 feet, which is just those are very long spans for a concrete structure. In Michigan, in the early 1980s, Michigan is largely a steel state, or was traditionally largely a steel state. And so this bridge, the bearings were over-rotated. There was some damage to the bearings. There was an initial attempt to replace just some of the bearings at the expansion joints in the early 2000s, which resulted in damage to some of the tendons on the bridge. And one of the bridges was closed for an entire summer. So again, that adds to the public, distrust of this bridge. So we kind of rescoped and refigured out, how do we want to deal with this bridge? How do we need it? We need this bridge to last another, 50 plus years for us. And so we set about, it was one of the first CMGC, construction manager general contractor projects that we did. And we spent 2 years in the design of this thing, figuring out ways to, lift the bridge off of the piers. Some of the jacking loads were as much as 15 million pounds. And we had to do it about 49 times. And so we worked with a really good contracting team, really good consulting team, and everybody was on the same page. We had a lot of issues that we had to work through in doing such a complicated thing, But 2 years in construction, and then or 2 years in design, excuse me, and then when it went into construction, I was asked to be the resident engineer to see that the design was properly built, which was a huge thrill for me. I got to live in a trailer under the bridge for 2 years, which was awesome. It wasn't easy. I'm surprised I don't have gray hair because of it. But after 2 years of construction, we reopened the bridge, well, both bridges, and this was back in 2014, and everything has been fine since. We reload rated the bridge, everything was great there. So that was one of those once in a lifetime projects where I got to be, the lead structures and PM during the design, and then be the resident engineer during the construction. So I feel pretty fortunate to, be part of that. And then another project that started, I went to my first project meeting in 2005 that is still ongoing. And here at RS&H, we are working on it as well. And that's the Gordie Howe Bridge, which, I could talk for hours about that one. So, but yeah, the I-75 over the Saginaw River, that was a big one that was really an achievement, both technically in terms of replacing bearings of a bridge of that nature, but also we learned a lot of MDOT staff that was on that project. There was a new generation of staff that wasn't there when that bridge was designed or built, so we kind of lost our knowledge on how to design and maintain, post-tension segmental bridges. And through that project, a lot of staff gained that knowledge. It was awesome.
One of the things about our industry is the public expects when you go over a bridge that it be safe and secure, that everything be in order, and to have a project like that where you have doubts and the public has doubts had to be an incredible burden, not only on you, but on the entire project team, and a lot of pressure to get it right.
Yes.
And so when you went through that process, what'd you find in terms of on the design side, the toughest issues to deal with? And then I want to move over to construction, talk about that a second. So since you had both of those, what do you see on each side of that, on the design side and then on the construction side?
Yeah, so with a bridge like this, precast segmental, it was built with a large gantry system. It was a self-propelling gantry that would lift the segments into place. You'd post-tension them, and then the thing would launch to the next cantilever. What happens on a bridge like that is you have loads on the bridge, and then you change its statical determinacy from a cantilever to, when you put that closure pour in, you change it to a continuous span. Well, all of those construction loads have to be accounted for, and they end up being locked into the bridge. And so when we are looking at coming back and actually lifting the bridge, we have to take all that into account. And the other interesting thing too was we had to lift the bridge in points where the natural, the existing bearings, where the bridge has, the required size of concrete elements and size of rebar and post-tensioning to run the load into the bearings. Now we're moving that out into where we're putting jacks to lift the bridge. So we had to do quite a bit of analysis to make sure that the bridge could handle the jacking loads without disintegrating. We had to do a lot of external strengthening. And then we were even actually, we were able to go back through the construction archives, and we found certain segments that were built. We found their 28-day compressive strength tests from the 1980s, whereas the design was 5,500 PSI. The 28-day strength was actually 7,400. We were actually able to take those values, plug them into our models to make sure everything worked. So it was a huge technical challenge just to analyze the bridge to be lifted when it wasn't originally designed for that.
So you're looking at the past, you're understanding the current status, and then you're trying to put everything in place for this construction. And then you switch, once you do all those calculations, once you solve the technology and technological problems, and now you move over to the construction side. Tell me how that worked for you, and what was fascinating about going from the design, sort of the paper side, into the field.
Yeah, so one of the major things we had to take into account was it's a big hollow box section. And so you've got jacks on each side, and those jacks have to actuate at the exact same time. You can't have one jack that strokes higher or lower than the other, because that puts additional torsion into the bridge. And so we worked with a jacking manufacturer to come up with these jacks, and then a custom manifold that applied equal pressure to 8 jacks throughout, on the column that would lift the bridge. So that was a big one. And then ultimately it was just a function of, okay, all the theoretical pieces are in place. Once we first started that first, lifting operation, um, very, very stressful. We only had to lift the bridge about a half-inch to disengage the existing bearings. But again, it was 15 million pounds that we're putting in. So, I was, and I've got pictures, I stood right under where all the jacks were, and everybody else was kind of off to the side. And my, you know, mode of operation that day was, well, we've done everything we could. If something were to happen in this bridge, something happens, I'm under it anyway, so I won't be able to answer any questions as to what went wrong.
Well, that's certainly knowing you were on the front end of that and doing the design and getting things in place. You had to have some level of confidence that you looked at every aspect, and then you turned that into your work in the field. It's a fascinating, and as I asked, I said, "What is a particularly challenging bridge?" This seems like an absolutely extraordinary challenge. What were some of your lessons learned after the fact?
After the fact, or even during everything, I realized that for a project that complicated, having the contractor on that journey with you, because it's a CMGC, I learned that the contracting industry sometimes has better ideas than the original designers. They're envisioning how they're going to build it. They're also thinking about how they're going to make a profit, obviously, but they're thinking about how are they going to build it, logistics, how do they maintain safety, all of these things that we don't necessarily have to think about when we're working on the design and staring at a set of calculations or a set of plans. And so that project really opened my eyes to just the value of what contractors bring to our projects. And I've been very just open to their opinions and perspectives ever since. It was very eye-opening.
And certainly at RS&H now, as you work with contractors, as you're thinking about opportunities from CMGC to design build, that experience helps you formulate the best team to take to now that you're not on the client side, to clients to deliver. And must be a fascinating time for you as you can look back on those 20 years at MDOT and now look forward to how you can help DOTs across the country.
Yeah, it's something that I'm really enjoying. We're helping right now. We're helping the Illinois DOT with their first CMGC, and RS&H just got an as-needed contract with the Office of Major Projects with the Michigan Department of Transportation. So hopefully I can continue to help here in Michigan. So yeah, it's hopefully it's a perspective of understanding what it's like to be in the owner's shoes, right? There's no greater really responsibility than owning and operating a transportation system. It's something that would keep me up at night, when I was in the position. So it's knowing what the owners are going through, knowing what the expectations on the owners, that I hope that I can bring to the table.
Well, this leads me to my next question, and that is the issue of safety and environmental impact. How do engineers in particular address safety concerns and environmental impacts when designing and building bridges? What is the lens that you look at? And can you tell our listeners a little bit about how you do that?
Sure. I mean, there's the standard, processes which are within NEPA that obviously we have to follow. But the interesting thing about bridge projects moving forward and some of these major projects, right? So you look at like the Gordie Howe project here in Michigan, you look at the Brent Spence Bridge replacement between Cincinnati and Covington there. You look at just any major bridge program that's going on right now. the standards, the current standards that we design to AASHTO, I mean, they have baked in all of those safety things, right? That the members have to be proportioned for the anticipated loading. But what's going on, I think, nationally on these larger projects is owners, when they make that investment, they're saying, I don't want this bridge to last only 75 years. I want it to last 100, 125 years, right? So now we're challenged when we look at our design to maximize materials. And if we're going to put an expansion joint somewhere, where do we want to put that? Or can we remove it completely? And what type of coatings are we using? And how are we selecting different elements in concrete so that we lower its permeability or lower its properties, its coefficient of diffusion so that water doesn't get to the rebar? These are things that, again, the codes always did a really nice job of making sure we were thinking in that lens as far as, load carrying capacity and safety. But as we get into these bigger programs, owners are actually demanding more. They want us to think further down the road, think, okay, with this investment, how can we ensure safety for, 100 years, 125 years? How can we build in, yes, this element can be replaced easily, right? So another generation doesn't have to go through what I did on Zilwaukee Bridge on I-75. How do we build those things in now so that 50 years from now, 75 years from now, engineers can safely replace elements and safely strengthen or modify the bridge? So those are things that are being baked into the design now that I think help make bridges, obviously serviceable and safe into the future.
Well, it's a different dynamic too, because major bridges and major construction projects like a major river crossing also cost an enormous amount of money. And so that investment is where the owners want to see the payoff over the long term. And you've seen as the chief bridge engineer for Michigan DOT, that push and pull between getting a product that'll last a long time, making sure it's safe, making sure it's environmentally sustainable, and providing the resilience that you need for that longer term. That's a lens that I'm seeing now in our industry where resiliency becomes part of the overall equation. Are you seeing the same thing?
Absolutely. Yep. And it's resiliency on tons of factors, right? It's, resiliency against flooding, or it's resiliency against a vessel collision, or it's just resiliency of the harsh environment that we put that bridge in. Yes, resiliency is a huge, huge part of, again, how do we think about the original design? How do we think about how this is going to perform in the future? And then a future generation that's going to have to take over taking care of it. How do they then carry the torch and make this bridge last as long as it does? I mean, think about the Brooklyn Bridge. I mean, that bridge was opened, I think it was 1877 or something like that. And it's still used to this day. Granted, it's repurposed, for modern need, but this is a bridge that has been in service for that long because the owner understood what investment was needed to keep it going, and they do what's needed to keep the bridge safe. And that's where it goes outside of what do we design it to, and how do we have the processes and procedures and policies in place for in-service inspections and load ratings, and when do we scope this thing for a rehab project and all that stuff. That's all baked into what an owner has to deal with on a daily basis. And that's what we want to help them with.
And we see that challenge with the major projects, the big bridges like you've described, whether it be Gordie Howe or the Brent Spence, and I'm very familiar with the Brent Spence, having lived in the Cincinnati area for a couple of decades. And so we see that, but it also applies to smaller structures where the useful life, where we think about that, we want to expand that so that we can expand the overall life cycle and gain more from the investments that are happening in our bridges. Are you seeing the same thing with some of the smaller projects as well, just on a different scale?
Yeah, exactly. So we've been talking about these huge, massive projects, but I mean, just think about the local river crossing in a downtown area. That is somebody's lifeline to access to services, right? Access to the grocery store, or heaven forbid, there's a medical emergency. So yeah, we think about these massive freeway bridges that take 100,000, 120,000 vehicles a day. But what about that small bridge across the small river in a downtown area that maybe only sees 1,000 vehicles a day? But that is a lifeline for that community. And so the same standard of care needs to be applied to those as well.
That's a fantastic point and leads me right into my next question. And that is this notion of what role bridges play in connecting communities and in fostering economic growth and development. What do you see and how important is it? You sort of touched on that a second ago. Can you elaborate on that?
Yeah, I mean, if you think about everything that's involved, the benefit of a bridge, right? So you have a crossing over some natural, I don't want to call it an obstacle, but I will. Let's say it's a river crossing or you're crossing another roadway. If you think about the time it takes, if a specific bridge wasn't there and the time it takes to go around or to do this or to do that, you really start to understand the importance of bridges and how they do connect on so many ways, on so many levels. One of my favorite quotes of all time is there's actually a plaque on it's I-5 over the Columbia River. It's the Interstate Bridge Replacement Project that Washington State and Oregon are trying to fund right now. The original bridge was commissioned, was opened, I think, in 1917, right? So over 100 years ago. And there's a plaque on the bridge, and I'll read you what it says. It says, "Of all inventions, the alphabet and the printing press alone excepted, those inventions which abridge distance have done the most for civilization of our species. Every improvement of the means of locomotion benefits mankind morally, intellectually, as well as materially, and not only facilitates the interchange of the various productions of nature and art, but tends to remove national and provincial antipathies and to bind together all branches of the great human family." This is a statement about a bridge over 100 years ago. Somebody had that foresight, and I think the same is true today.
What a wonderful quote, and certainly shining from 100 years ago the light on everything that we're facing in this industry right now, because many of those bridges that were built 50, 75, or 100 years, we're either rehabbing or we're reconstructing or we're adding capacity, or in your, as you noted earlier, we're fixing a key component so it can stay in service for much longer. That's an incredible quote, and I appreciate you sharing that with our listeners. In your opinion, I want to talk about some trends in advancements. What trends in advancements do you foresee in the field of bridge engineering in the coming years? Let's start there along this trend or advancement scenario, because a lot is happening in technology and delivery and design and construction. Talk about that for our listeners.
Yep. So we touched on one of the major developments, and that is owners are simply wanting more out of their bridges. They're wanting more service life. So you need to do your best in addressing that in the original design. I think the other thing we're seeing too is, with some of the environmental things going on with climate change, there's several situations where a culvert that was built 60, 70 years ago in a river was fine at the time, but now that we come back and we try to modernize, we find that that culvert is no longer enough. You have to have a much wider hydraulic opening. You have to account for a greater rainfall intensity and greater flooding. So there's owners are challenged with the fact that, yes, I have this piece of infrastructure that's there now, but if I go to replace it, it's going to cost much, much more. And therefore, again, with that investment that they're putting in, they want to get the most out of it. So how do they do that? Longer service life. We're looking at the use of different materials, stainless steel in bridge decks, or even non-metallic types of rebar like like FRP elements. Um, and then the one thing that happens over and over and over again on every project that has to be analyzed is, well, what are the impacts to mobility? And oh, by the way, how can we get those close to zero as possible? So you see a lot of prefabrication up front. You see a lot of building as much of the structure as you can um, offline and then moving it into place. And that's not a new concept, by the way. That's been going on for since we started building bridges. But there's such an emphasis on if you've got an existing system that you have to upgrade or completely replace, how do you do that? Build it on a new alignment and shift traffic over. So it's the thought that goes into how do you stage a bridge? How do you realistically determine what the construction schedule is going to be? There's a lot of thought put into that upfront, which I think is just growing and growing again with these larger programs. But again, it all goes back to how do we design and build a bridge that is going to last longer than our previous generation designed and built bridges, and that's really the trend.
Well, how does, from your standpoint now on the private consulting side, advising owners, how does your perspective as a former owner help you advocate for the new advancements, the changes that you're seeing, whether they be materials or in design elements or in lengthening that life cycle? Can you talk about your uniqueness in helping clients today, having had the experiences you've had?
Yeah, so unfortunately, I think a lot of us, we learn trial by fire, right? It's a rite of passage. It has to be a specific percentage of our learning because that has the most impact. And I've done a lot of learning trial by fire, and where I hope to make sure somebody else, an owner, doesn't have to learn that same painful way is I like to get in front and have the discussion of, okay, if we're going to do this, what about this, right? So for example, when we first started doing carbon fiber pre-stressed beams in Michigan, the fabricators had a real issue handling those materials properly. How do you actually stress a carbon fiber strand in a pre-stressing bed that was designed for stressing steel strands? And so we had to come up with whole new processes for how we did this. And yeah, there was a cost associated with that, and there was a time component of that as well. And when other state DOTs started asking questions about, okay, we want to try this. I remember I was working with Ohio DOT at the time. I was able to take what we learned in the first couple of projects we did and say, okay, you got to think of this when you put your contract documents together, and you got to think of this when things go to the fabricator. Have some training, have this, have that. So it's those experiences that you go through whenever you're going to try something new, whenever you're going to innovate. You're not going to get it right the first time, but what you learn from that is knowledge that you can pass on to somebody else who's looking to do something similar. And that's where I see, hopefully, my value within RS&H and helping us with our clients.
Well, I think that's a great a place to come from where you've had those experiences. You were in a DOT that was also very progressive in terms of looking at that future, understanding where you needed to go, and giving you some latitude to try some new things. So that also helps in that process. One thing I think about often is as you and I, we've spent 20 years at the DOT. I spent 20 years at the DOT. Those experiences now on the private side help inform us because we sat in that client seat, and it's so valuable to have those experiences to carry them for the future generations, not only future generations of DOTs, but future generations of bridge engineers. And so that's where I want to ask my final question. Uh, as you think about bridge and structural engineering, what advice would you give to an aspiring bridge engineer or those who are interested in pursuing a career in the field of bridge or structural engineering?
That's a great question. This is something I actually do quite a bit with my students when I teach. And I spend my first class. We don't do anything technical. All I do is give them statistics of the bridges that we have in the United States, right? So in the United States, we've got over 600,000 bridges, and those are the ones that are actually in the National Bridge Inventory. There's probably thousands of more private bridges and other bridges that aren't inventoried that we are going to start inventory with the changes in some of these rules. So you got, but let's just go with the 600,000 number. You got the 600,000 bridges. We've been building bridges for 200 years. So it's not like we built 600,000 bridges 100 years ago and they're all at the same spot and we can replace them. No, we have to make decisions on, do we replace this one? Do we modernize this one? Do we rehab this one? But with the 600,000 bridges in the US, that averages to be about 14 to 15 bridges per 100 lane miles of public roadway. So if you start putting all these numbers together, you see that it's a great time to be a structural engineer, be a bridge engineer. There is a huge need. Most of the owners of bridges are public transportation agencies, and they are simply under siege with the massive responsibility that they have relative to public safety. And for us to be in a position to help an owner, whether it's from our technical expertise to help design or analyze something, from programmatic expertise to say, hey, you've got this bridge project, or you got this bridge program, why not think about design build or progressive design build to help deliver this, more efficiently? Or even just on the construction side, right? You've got construction engineers that the line between, designing a set of plans and throwing it over the wall to the construction engineer, that line is blurred all the time now as we think about, yeah, you can design a bridge, but the bridge also has to be built. And what kind of loads and what kind of stages are on the bridge before it's even complete that you have to take into account so that the construction engineering piece can be just as interesting, if not more interesting and more complicated than the original design. And as a structural engineer, you get to do all that. And then once it's built, you get to be part of the life cycle decisions and how do you maintain it? How do you keep it safe? And so if you just think of the sheer volume of 600,000 bridges, and then you look at the major bridge programs, these once in a lifetime, once in a career projects like Gordie Howe, like a Brent Spence, like I-10 over the Mobile River in Alabama, it's an exceptional time to be a structural engineer. And I can think of no better, method of recruiting than just those statistics and the fact that you could aspire to be involved in all that.
Well, and that starting your class with those kinds of numbers and understanding that, but also sort of saying we have a need for efficiency. And we talk about efficiency in all kinds of different ways, from business to government, and all of that. But it's true in the sense when you have 600,000 bridges, the need to be efficient and effective at the same time is so critical because it's literally driving those investments, those tax dollars, those user fees that come into the department or come into the federal government and making it real. That is a tremendous responsibility. And you've seen it now on both sides. Do you see that efficiency, this notion of better and faster, and in some ways maybe cheaper and longer lasting by virtue of the materials? That's really the challenge facing the next generation of bridge engineers. Wouldn't you say?
I'd say that that's part of it. Yeah. I mean, you definitely want to, if there's going to be an investment in public infrastructure and you're going to impact traffic and you're going to impact people's mobility, you have to be as efficient as possible. But it also comes into, the creativity and the thinking. I mean, if you read any ARTBA or ASCE report card, I think they say that, there needs to be trillions of dollars invested to get the infrastructure up to like a B+ grade or something. And what we're finding is it's nowhere near that, right? It's in the billions, which is great. Every little bit helps, but you've got trillions of dollars of needs and you've got billions of dollars in funding. You absolutely have to be creative, you have to be effective, you have to be efficient in how you're going to spend those dollars to maximize safety on the system. Absolutely.
And it's that safety underpinning that really drives everything. So all of the things you mentioned, the most important thing is safety. And that to me is something that elevates, every bridge and structural engineer that works on anything, whether the biggest and the longest structure to the smallest. It's that function of safety that really drives many that I've seen over my career in my 35 years, 36 years, watching this industry grow. There's never been a time where safety wasn't paramount.
Correct. Yep. And that's what the owners care about the most too, right? I mean, yes, they are under, they're under a lot of pressure to be fiscally responsible and make good decisions. But all of that always feeds up into safety.
How do you balance that and from talking to aspiring bridge engineers to being out in the field? What is your sense around the whole dynamic of safety?
So it requires very difficult decisions. And I explain this kind of from an ethics perspective in my class. We had a situation a number of years ago where we had a bridge that got hit. It was a railroad bridge. It got hit by a truck. And, you know, if it were an MDOT, if it were a regular vehicular bridge that got hit by a truck and damaged like that, we would have closed it. But that wasn't the case. This was it was a railroad bridge. It was not owned by the department, and the owner of the bridge, they did their due diligence. They ran through calculations, and they determined um, they could run their trains across the bridge. I was not comfortable with that, and I had to make a very tough decision. We actually closed the freeway below the bridge until it was fixed, and I caught a lot of heat for that, a lot of pressure. But at the end of the day, and I've spent a lot of time, again, as chief bridge engineer on interviews with, media stations and stuff like that. And I always tried to be very consistent with safety. But that particular situation, I had a lot of microphones in my face. And I basically said that I sincerely apologize for inconvenience. But it's a lot easier for me to apologize for inconvenience than apologize for what could happen if we didn't take this call.
Yeah.
And again, so it's something that unfortunately you're never gonna experience it until you're put in that situation. But sometimes when you put safety first, it's a tough call, and you just have to you have to make the call. You have to defend it, but it can be a tough call.
Well, thanks for talking about that because those are everyday decisions that bridge engineers make all across our country, and they're important ones because literally it's a life and death, or could be a life and death decision. Your ability to bring those kinds of learnings and teachings to aspiring bridge engineers is is just absolutely incredible. It must give you great satisfaction as you start off a class in a semester and see those minds that are interested in structural or bridge engineering, and you embark on that learning process. It's got to be very rewarding.
It is, and you said it right there, the learning process. I learn something from the students every semester, which is awesome. It's a lot of work by the time we get to the end and got to grade a ton of finals. I'm definitely looking forward to the end of the semester as much as the students. But you're right, I love it. I love being able to just be in that community with the students and knowing that that's what they want to be when they grow up, and hopefully I can help them get there.
Well, Matt, this has been an absolutely fascinating discussion around bridge engineering and structural engineering and all the dynamics of your own career and around your teaching. I want to go, and what we do on AEC Perspectives, we close out every episode with a number of rapid fire questions. So I'm going to throw some rapid fire questions at you. The first one is a little different. It's a little unique to you and not one I normally ask. But can you tell us about this certain Michigan PE, professional engineer seal? Is it right? You have a tattoo of the Michigan PE seal?
I do. Again, it was just, my lifelong dream to be a structural engineer. And so when I passed that exam, I was just so over the moon thrilled that I had arrived. Yeah, I went and got a tattoo of it on my arm. So if anybody sees me in any office and wants to see it, just pull me aside. I'll be happy to show it to you.
That's awesome because not only are you a professional engineer, you can show them the seal right on your arm. I
That's right.
love that. Uh, at RS&H, we have this essence that we call driven to care. And we exude that through all of our associates. And it's something that we focus on not only in our daily work, but in our dealings with clients and in our communities. When you hear driven to care, what do you think of?
So I think it's all encompassing, right? So for me, in the position that I have, driven to care means that we talk about the clients first, right? That I'm advising and providing just the best possible service and solutions I can. But when I think about our associates, and we've got a lot of great young associates, it's spending time with them. It's acting with empathy and putting myself in their shoes when they have tough decisions to make, and actually helping them. I must admit, in the few months that I've been here, I've met most of the young bridge associates, and I've worked with quite a few of them. Some of them in some tough situations, and I get just the most satisfaction out of working as a team with those folks, and coming up with a solution, or looking at, okay, what would happen if we do this? And we've done a lot of that in the last couple of months, and that has given me just a ton of satisfaction. So the driven to care piece is, for me, means caring about everybody. If it's a client, great. If it's a senior associate, great. If it's a younger associate, great. I want to act in empathy with all of them.
That's a wonderful answer, and it kind of leads into my next question. And one of the things that we see in our industry because of what you talked about earlier, the stresses, the complications, and the complexities that we deal with in our industry, it can wear on you mentally, and we have a focus on mental health and wellness. We think about work-life balance in a different way. What is the one thing that you do that supports your mental health and your wellness?
Well, as you mentioned earlier, I'm a runner, so that's one of the best things for me, to just get out on the road and try to let my mind wander wherever it wants to go. Now, it's 6 degrees right now here in Michigan, so I'm not getting out running. I'm down on the treadmill. But I will admit, and I think we all struggle with this. There's the work-life balance piece, but even the outside of work piece these days, with what's going on in the world, it's all stressors, right? I'm at the stage where my children are getting ready to leave and go to college. So is there anything, more stressful than that? So I will admit, there are times that I struggle to find a way to worry about my own, mental health, and try to elevate myself so that it doesn't become an issue. Um, so I don't have a really good answer to that one, Brian. I'm still figuring it out myself. But I do, like, yesterday is a perfect example. So Martin Luther King Jr. Day, we had the day off. Um, Yesterday was the first time in 20 years, even though I used to get that day off when I was at MDOT. Yesterday was the first time in 20 years that I did not log on to my email on a holiday. And it was weird to me, because I felt like, shouldn't I be doing something? But at the same time, at the end of the day, when I reflected on just having a nice, relaxing day, that's exactly what I needed to do. So sometimes we have to do that. It's not always easy, but sometimes we have to do it.
And if you're purposeful about it, if you're thinking about it, and as you run, that becomes a natural thing where you use that for your mental health and wellness. And
Yes.
thanks for sharing that. It's so important. Everyone has their own unique way of working through mental health and wellness, and some of us do it better than others, and it's a journey. That in and of itself is, in fact, a journey. My final rapid fire question is there a piece of advice that you've received or a quote that you want to share that is a mantra of sorts for you?
I do. And this again comes from my background as an owner, right? But I think it's true for all of us. So I had a colleague that I respected very much. She was at the time she was my deputy chief bridge engineer, and she is currently the chief bridge engineer for the Michigan Department of Transportation. And she said something so profound to me in a meeting once that I actually wrote it down, and I actually have it in a slide for my bridge class, and that is, we are at our best when we do our jobs and no one notices. And what she means by that, and what I mean by that is, if you think of the business that we're in, if we do our jobs correctly, whether it's designing something, building something, maintaining something, public will never notice. They get to use that bridge, they get to use that freeway, they get to, their flight leaves on time, it lands on time, right? And we are the ones in the background making all of that happen, and no one notices. And that is the way we want it to be, right? When people start noticing things, I once told a reporter that, look, if you have to drive around the Metro Detroit area and you have to look at a bridge and decide, are you safe going over it or under it? I failed at my job, flat out. You should never have to think of that. So it's just we are at our best when we do our jobs and nobody notices, because that means the public is safe.
What a great answer, and what a wonderful podcast session, and a great way for us to open up our second season. I am so pleased to speak with you, Matt, the National Bridge Group Leader at RS&H, Matt Chynoweth. Thank you for being here on the inaugural episode of our second season. Have a wonderful rest of your day, and thank you so much for joining me.
Thanks, Bryan. I really enjoyed this.
This has been another episode of AEC Perspectives put on by RS&H. Thank you for listening.